Okay, so we are discussing how I can apply this FIFO strategy, phrase replacement policy or strategy on this sequence of strings, okay, which are nothing but the page numbers requested by the CPU. Okay, so to solve this kind of problem, I have to make a table like this. There are other ways also to solve the same table, same problem, okay, like other ways means other representation. The process is same for every representation, but the representation that I am following is in this tabular manner. Some other representations are also there. I have to ultimately find out the number of page fault. Okay, so this kind of questions generally comes in exam. Since the number of frames are 4, here you can see f1, f2, f3, f4 I have given, right. Now on the bottom of this I can write this on the bottom, as well as I can write also on the top. On the top of this table I am writing the requested sequence. Okay, so I have to make those many columns only which are equal to the number of requested sequence. Okay, 7, the first one is 7, then 0, then 1, then 2, 0, then 3, then 0, then 4, I need to make more columns, 4, then 2, then let me make some more columns here so that I can accommodate the entire string. So after where I was 70 304 304 2, after 2 the request is 3, then 0, then 3, then 2, then 1, then 2, then 0, then again 1, then again 7, correct, then again 0, then this 1. Okay, so I will first draw this kind of table. Now what I will do, why I have made these 4 rows, because in my main memory I am having only 4 rows. Why I am making the columns? So that it will be easy for me to count the page fault. Okay, this there is actually only 4 slots only in the main memory. At different time these 4 slots will be occupied by different pages from those strings. Okay, so at first the entire main memory is empty only, right. So the first request, that is 7, whether 7 is there in the main memory, no. Then if it is not there in the main memory, that then what happens, page fault happens. So this page fault I am marking it with a star. Okay, page fault you can mark with any kind of symbol, because ultimately I need to count how many stars I will get here. Okay, that will indicate the number of page fault. So this star I am indicating with its star. You want to indicate with some circle or some triangle or whatever, with some human being, no problem, you can do. Okay, now 7 is there, fine. So what I will do, page fault has occurred, so now I will insert 7. That means 7 on demand, it has been brought from the secondary memory to the main memory. Then what is the next request? The next request is 0. Whether 0 is there in this particular main memory, no, right. So again page fault will occur, but for the second time already 7 is there, right. So 7 I will write. Okay, in the frame 1 7 is there, so that I will continue. In the frame 2 now 0 I will bring from the second memory. Okay, then for the third time 7 will also already be there in the frame 1, 0 will already be there in the frame 1. Then the third demand is for the page 1. So now 1 will occupied in the frame number 3, correct. Even 1 was not there previously, so page fault has occurred. Then 7 0 1 already there in the main memory. Now the next request is for 2. Okay, 2 is not there in the main memory, so page fault will occur. Now I will bring 2 from the secondary memory to main memory. So initially for each and every page required pages, page fault will occur, because it is not given that the memory, main memory is already having some of the pages or not. Okay, it is not given, that means we will assume that main memory is empty. Okay, then after 2, what is this next request? Next request is 0. So I am already having 7, 0, 1 and 2 in the main memory. Whether 0 is there in the main memory? Yes, it is there. So there will not be any page fault. Then the next request is 3. So I am already having 7, 0, 1, 2. Is 3 in the main memory? Is there in the main memory? No. So page fault will occur. Now whenever page fault occurs, what happens? What we need to do? Whenever page fault occurs, if no free frame, yes, no free frame, and page fault has occurred, I'll replace the new page with page arrive first. I'll replace the newly requested page with the page which has arrived at the beginning, at the very first. So at the beginning, which page has arrived? 7, right? So 7 is the oldmost page. It has come at the beginning, it has come at first to my main memory. So I'll replace 7 with 3, 0, 1, 2. Remaining pages will be as it is in the frame. Then again the next request is for 0. Whether 0 is there in the main memory? Yes, so no page fault. Then next request is 4. Whether 4 is there in the main memory? No, 4 is not there. So which particular page I will replace? I will replace the first page. Okay, currently among 2, 1, 0 and 3, which is the first arrived page? That is 0. 0 came second, right? That is 0. So what I will do? 3, here I will write 4, 1, 2. Okay, so it is page fault will occur. Okay, generally we forget to count this page fault, that's why we are marking it star. But even sometimes these are some silly mistakes, even we forget to mark with star also, mark that particular page fault. Then the next request is for 2. Whether 2 is there in the main memory? Yes, so no page fault. 3, 4, 1, 2, I will write as it is. Next page request is 3. Whether it is there? Yes, so no page fault. I will write as it is. The next request is 0. Whether it is there in the main memory? No, so page fault will occur. Which page now I will replace? The page which has come the first. Among 2, 1, 4 and 3, 1 is the one which has come at the beginning of all these 4. Okay, so now I will replace 1 with 0. So rest will be as it is. Then again the next request is for 3. Whether it is there in the main memory? Yes. Then next request 2. Whether it is there in the main memory? Yes, so no page fault. Then the next request is now unfortunately 1. Whether it is there in the main memory? No, so page fault has occurred. Which one I will replace? Among 2, 0, 4 and 3, 2 is the one which has came first, right? Because 0, although it has come long before, but it got replaced and then it has come newly, this 0. So 2, 0, 4 and 3, I will now replace 2. So here also some of the students may have this kind of silly mistake, that it may replace 0, but I have to replace 2. Okay, then again unfortunately the next request is also for 2 again. Whether it is there in the main memory? No, page fault has occurred. I will now, which one I will replace? Just now I have replaced with 1, right? I will not going to replace it. 0 also I have done, 4 also is done, but before that 3 I have this 3 is the one among all these 4, the oldest one, right? This has come first. So now I will replace 3, 1. Okay, rest as it is. Then again next request is for 0. Whether 0 is there in the main memory? Yes, it is there. No page fault. Now 1, yes, it is there in the main memory, no paste fault. Then 7, whether 7 is there in the main memory, unfortunately no. I have to replace 1 has come recently, 0 has yes, it has come, no, last was 3 which got replaced by 2. After that the oldest one, the one which has come first is 4, I guess, yes, because 0 has come here, yes, 1 has come just now, so I will now replace 4. 7 will be replaced by 4, rest will be as it is. This one is paste fault. Okay, again I forgot to mark the paste fault, so this is paste fault. 0, again 0, no paste fault. 1 0 7 2, 1 is also there, no paste fault. 7 2. So I will now count the stars, how many paste faults are there. The number of paste fault will be 1 2 3 4 5 6 7 8 9 10. So total 10 number of paste faults are there. Okay, so this is the answer. These 10 number of paste faults are there when your number of frames are 3. Okay, sorry, when your number of frames are 4. But if your number of frames are 3, if I reduce the number of frames, then what is the total number of paste fault? Again we will solve that one as well. Let me accommodate that those here only. We'll try to the process is similar only, okay, but one fact that I want to show you, that's why the same process I am repeating for 3 frames. This time the only change is that the number of frames are 3, so I will be having 3 rows here, F1 F2 F3, correct. So my request will be as it is. Let me first have some slot here. So okay, here let me write 701 the request, 203, then 042 303, sorry, yes, 042 303, then 212, after that 212, 017 then 01, then 0 and 1. Okay, so here also one we may sometimes, these are silly mistakes that we may do, that when writing this sequence from the question paper to your answer script, sometimes we may do some mistake. Okay, so be careful in that. I just want to verify the count: 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. 20 are there. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20. Yes, correct. Okay, so again same thing I will repeat. First 7 requests, whether 7 is there, no paste fault, yes. 0 is there, no paste fault, so 7 0. 1 is there, no paste fault, 7 0 1. Then whether 2 is there, no, so paste fault. Which one I will replace? The one which has come first, so 2 0 1. Then 0, whether it is there, yes. 3, whether it is there, no, again paste fault. I will replace the one which has come first, paste fault it is. 0 is there, no, then I will again paste fault it is. I just have replaced 2. Okay, fine. 3 also just now, so old one is the first one is 1. Again whether 4 is there, no pace fall. So 2, which one I'll replace, sorry, 0 just now I replaced, 3 also just now, 2 is the oldest one, 2 has come first, 4, that's why 3 0, again 2, the request is 2. So it is a pace fault, I'll replace the old one. So 4, the old one here is 3, so 2 0, again 3, pace fault, 4 2, I'll replace here 3, again 0, again pace fault, then 3 just now, then okay, 4 I'll replace because it has come first, right, and 2, then 3, then 3 again, fortunately we are having it, no pace fault, 2 again, fortunately we are having it, no pace fault, 1 again, we are not having it, which one I'll replace, I'll replace 2, right, that is the first one now, 1, so it is a pace fault, 0 3, then again 2, sorry, it is a pace fault, 0 is this one, 3 is the first one, right, so I'll replace here 2 1 0, 0 no pace fault, it is there in the main memory, 1 no pace fault, 7 pace fault. So which one I'll replace, 2 just has come, 1 also, okay, the old one is the 0 one, right, it is, I can see 0 from long time, but 1 only this much time, 2 only this much time, okay, this is how we can identify in this table. So I'll replace here 7 1 2, correct, and it is a pace fault. Unfortunately the next request is 0 again, so just now we have replaced 0, right, but again it has come, so now I'll replace 1 here, it is a pace fault, 7 2, again it is 1, I'll replace now the oldest one, that is 2 1 0 7, it is a pace fault. So this time what is the number of pace fault, it is 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15, total 15 number of pace faults are there when I have considered 3 frames, and that is also justified in a way that if the size of my main memory is smaller, okay, then the possibility of pace fault is also more, okay, that is uh, a general understanding that if the size of my RAM is more, okay, I can run more and more programs maybe, but if that size is less, then uh, things will be slower, right, my processes will run but it will be slower. Why? Because most of the time will also be spent in replacing all these pages, the OS will be busy there, okay, but that is not the case always. This is all about the FIFO. Next we'll see, okay, this is 10 then 15, again another reference string also I have given, and you have to count the total pace fault, you do it by yourself. There is this concept called Bilard's anomaly, okay, what is it? It is a phenomenon in page replacement algorithm where increasing the number of page frames Okay, due to some issue in the laptop, it got set. Let me continue. So what is Billard's anomaly? So when we increase the number of frame unexpectedly, it will increase the pace fall also. That is a reverse phenomena, which is not observed in this previous example. Okay, here I have increased when the number of frames is more, the pace fall is less. But the Billard's phenomena said that in some of the cases, even if the number of frame is more, the pace fall is also more. Okay, some that example also we'll see. Actually, for this particular example only, you will observe that even if number of frame is here more, right, still pace fall is more. But in the previous example, number of frame is more but pace fall is less. But in the second example, it is the reverse one. Okay, so that phenomenon is called Billard's anomaly. Okay, this anomaly violates the assumption that adding more memory should always reduce the pace fall. It is not like that. Adding more memory sometimes will not reduce the pace fall. Okay, so that's all for this video.